Okay, with question 2, there's kind of like two stages to it, because it talks about the first stage where the car decelerates uniformly from a speed of 20 to a speed of 12 as it travels a distance of 640 meters. So that's like the first stage. And then it says then it then accelerates. Okay, so that's the second stage. So in the first stage it decelerates, it's slowing down, yeah, but in the second stage it's accelerating. So we want to sort of have that in mind when we do Suvat equations, okay? So we've got to think that the Suvat here will be different, okay, for the second stage, all right? Because in the first stage, the acceleration, well, in fact, is a deceleration, so it's going to be a minus acceleration, but then in the second stage, it's accelerating, it's going to be different. So in the first stage, it tells us, doesn't it, that it starts at basically, okay, well, we pick up the story when it's going at a speed of 20, okay, and it decelerates, okay, so that its speed ends up being 12. So its initial speed is 20, and then its final speed is 12. And during this time, it's travelled a distance of 640 meters. Okay, so that's the first stage situation, and that can help us then to answer A, part 1. So it says there, find the time it takes for the car to travel the first 640 meters. Well, for the time, okay, we can use these here. Okay, and let's think about what formula we can use. Well, we've got U, we've got V, we've got S, we've got T. The one I'm thinking of is S equals 1/2 U plus VT. Okay, that's the one I'd use there, because we don't know the acceleration, don't we? Or the deceleration, rather. Okay, we don't know what that is, so I can't use anything with A involved. So that's the only one without A. So if I plug in the numbers, 640 is half. U is 20, V is 12, and then your T then is what we're going to work out. So if I do this then, work out the bracket 32, halve it is 16. So then to get T then, we just do 640, okay, divide by 16, and that comes out to be 40 seconds, okay. So that's the time it takes to travel that distance. Part 2 then, it talks about then find the deceleration, so we want A. So to get A, well, we could use V equals U plus AT, couldn't we? We could use that. Or we could use V squared equals U squared plus 2AS. Now I'm tempted to use the latter one I mentioned there, simply because if I use V equals U plus AT, I've got to use the time I worked out here. Now that could be wrong, couldn't it? I could have made a mistake there. So let's use this one. So V squared, well, that's 12 squared. U squared, that's 20 squared. 2A and S is 640. So if we work all this out here, okay. Right, check all these on our calculator, of course. So we've got that situation. Now, what I could do now is take the 400 over the other side, take it away, because you can't put these together. You can't put 400 and 1280A together. There's an A term there, so you've got to keep that separate. Take the 400 over there, becomes a minus 400. Okay, so this will be minus 256 equals 1280A. And to get A then, of course, I need to take this over, right? So, and divide. So 256 divide by 1280, and you get 0.2. And of course, there's a minus 0.2. Okay, so it's going to be a minus because it's decelerating, isn't it? So what we can say there is minus 0.2 meters per second squared, but we can actually state there, and look, the deceleration is 0.2 meters per second squared. So we don't have to put minus when we mention the word deceleration. Okay, part B, it says find the acceleration of the car as it travels the further 1,820 meters. This is like the second stage. So the second stage, if you think about the second stage, it sort of starts off with a speed of 12, isn't it? Because it starts off where this stage finished, okay, which was a speed of 12 there. So we're starting off now, second stage, with a speed of 12. It travels, it says further, it travels what, 1,820 meters in a time of 70 seconds, okay? And they want us to find the acceleration, okay? So to get the acceleration from here in part 1, we're going to have to use s equals ut plus half at squared, okay, because those are the values we know. We know s is 1820, we know u is 12, we know t is 70, we don't know a, of course, that's what I'm working out, and we know t to be 70. Okay, so we do that. So we've got 1820 here, okay, that's going to be 840 there, okay, and then we've got 1/2 a, and then 70 squared is 4900. Okay, so what I'm going to do then is take that over the other side and take it away, and then half of 4900, 2450 a. Okay, so when I take these away then, I'm going to get 980. Okay, that will equal to 2450 a. And to get my a, I've got to do 980 divided by 2450. Okay, so if I do that on my calculator, I get 0.4. Nicely, right? 0.4 meters per second squared. Okay, so then it says find the speed of the car when it's completed the further. So now we essentially then we want v, don't we? Okay, so from here then we want the v. Okay, so to get v, well, we could use that answer there, or we could use instead this formula here. Okay, so if I use that formula, I'm not using that answer because I could be wrong there, couldn't I? So we've got 12 plus v times t. Okay, so using all the values I know up here. So that would be half times 70 is 35, so times them together, 12 plus v. Maybe then times out the bracket if you want. 35 times 12 is 420. 35 times v, 35v. Take that over, so I get 1400 that side, 35v. So then v will be 1400, divide by 35, and I get 40 meters per second. Okay, now you could have used v equals u plus at there or something, right? Would have been a bit quicker maybe. You can check both ways really, can't you, to see if it's right. Then it says find the average speed of the car as it travels the 2460. So remember now, for average speed, okay, average speed is total distance, which is 2460, over the total time. Okay, now remember the total time will be the 40 seconds initially, plus then the 70 seconds which we told. So we were told the 70 seconds and we worked out 40 seconds before. So if I work that out on my calculator, it comes out to be 22.4 meters per second. That's the average speed there.